Hi everybody, welcome to Unit 2, Video 1. If you do not have your Show Me What You Can Do notes, please go get them right now. Okay, so topic 1 says, I can find the value of k so that the given line has a slope of m. So what you would need to do first here is first you have to get this line, kx minus 3y equals 7, into slope-intercept form. Right now it's in standard form, so we're going to convert it into slope-intercept form by subtracting kx from both sides. So we're going to get negative 3y equals negative kx plus 7. Then to get y all by itself, we're going to divide each side by negative 3. And we're going to get y equals a positive k over 3x minus 7 over 3. All right, so now that we have this in slope-intercept form, we need to identify the slope. So remember, the slope is the coefficient of x. So it's this whole thing right here, k over 3. And since they're saying m equals 2, m is the slope, it's the coefficient, we can set 2 and k over 3 equal to each other. So we're going to say 2 equals k over 3. So now that we have that, we can multiply 3 to both sides. So we're going to get 6 equals k. Oops. So here's our solution, 6 equals k. All right, so for the next one, we're going to do a very similar thing, except the difference here is this k plus 3 is now in parentheses. It's a whole quantity, so we're going to move all of it. So we go subtract the quantity k plus 3x from both sides. So that's going to give me negative 3y equals negative parentheses k plus 3x plus 1. Then we need to divide each side by a negative 3 to get y all by itself. So now we're going to get y equals a positive k plus 3 over 3x minus 1/3. And again, we want to identify m, or the slope, which is all of this right here, and the coefficient of x. Since m is equal to k, I can substitute and set them equal to each other. So k equals k plus 3 over 3. So the first thing you want to do is get rid of the 3 in the denominator. So I'm going to multiply 3 to both sides. So I get 3k equals k plus 3. Then I'm going to subtract k from both sides. So now I'm going to get 2k equals 3. Divide each side by 2. Divide by 2. So I get k equals 3 over 2. So that's my answer for k. All right, for the next set of problems, they're not giving us equations of lines anymore. They're giving us 2 points. So they're giving us 2 coordinates, and then they say m equals 3. So in order to do this problem, we have to know the equation for slope, or for m. So m equals y2 minus y1 over x2 minus x1. So we're going to substitute all of these things into our equation. Here's x1, here's y1, here's x2, here's y2, and m is equal to 3. So we have 3 equals k minus 4 over 8 minus 9. So when we simplify, we get 3 equals k minus 4, 4 over negative 1. So then our next step is we're going to get negative 1 out of the denominator. So we're going to multiply negative 1 to both sides. And so we get negative 3 equals k minus 4. And so then we want to get k by itself. So we're going to add 4 to both sides. So we get 1 equals k. 1 equals k. All right. So what I want you to do now is I want you to pause the video and I want you to try number 4. Okay, so let's go ahead and see how you guys did. So when you substituted everything in here, in the denominator, we got 1 minus 2k. So remember, to get that out of the denominator, we had to multiply by the quantity 1 minus 2k to both sides. And you need to make sure you're distributing that 2 to both of these that are inside the parentheses. So then when you do all the computation, you should get k equals 1. All right, let's take a look at the next Roman numeral. Given 2 coordinates, I can find the equation of the line in point-slope form, slope-intercept form, and standard form. Oops, All right, so in order to do this problem, you have to know what all of those things are. So remember, point slope form is y minus y1 equals m parentheses x minus x1. So this is point slope form because you're given a point, x1, y1, and a slope. Slope intercept form is also our graphing form. So it's y equals mx plus b because m is the slope and b is the y-intercept. In standard form is ax plus by equals c, where a cannot be negative. So it cannot be negative. And you cannot have a fraction. So no fractions. All right. So in order to do all these three forms, the first thing we have to do is find the slope. So remember, this is x1, y1, x2, y2. So m is going to equal 4 minus 2 over 9 minus 6. So here we're going to get 2 over 3. So our slope is 2 over 3. So the first thing you want to do is plug it into point slope because those are the two things you have, the slope and the point. Technically, you can use either one of these, but we always want to use the first one just for the sake of consistency. So we're going to say y minus 2 is equal to the slope, 2/3, x minus x1, which is 6. All right, so now that I have this, this is point slope form. And I just abbreviated there, okay? So to get it into slope-intercept form, we have to distribute the slope to what's inside the parentheses. So we have y minus 2 is equal to 2 over 3x minus 4. Then I need to isolate the y, so I'm going to add 2 to both sides. So I get y is equal to 2 over 3x minus 2. So this is slope-intercept form. Okay, so now that I have it in slope-intercept form, the last form is standard form. So I need to subtract the 2/3 x. I need to move it to the other side. So subtract 2 over 3x. So now I have negative 2 over 3x plus y equals negative 2. So I can't have fractions. Or a can't be negative. So in order to make those two things disappear, I need to multiply by a negative 3 to get rid of the negative and to get rid of the denominator. So when I distribute here, I'm going to get a positive 2x. And remember, you're distributing to everything. So then I get minus 3y equals a positive 6. So 2x minus 3y equals 6 is my equation in standard form. All right, I want you to pause the video and I want you to try number 6. Remember, you're starting by finding the slope, then you're getting every other, and you're walking through all the rest of the steps. Okay, so let's see how you did. Our slope was negative 3/4. Once I plugged everything in, here's my point slope form. Y minus 7 equals negative 3/4, x minus 4. Then I simplified and got my slope intercept form. So y equals negative 3/4 x plus 10. And then finally my standard form, 3x plus y equals 40. All right, so let's go on to page 2. All right, so page 2, again, we have to go ahead and start by finding the slope. So we are going to do 3 minus 3 over 4 minus a negative 2. So I'm going to get 0 over 6. And when I get 0 over 6, I know that's going to simplify to 0. And so now you have to ask yourself, or what do you remember, what kind of lines have a slope of 0? Well, horizontal lines have a slope of 0. All right, so we already know that this line is horizontal. So if you had a xy axis, here's xy, a horizontal line is going to cross through the y-axis like this. All right, so since we have a slope of 0, I can plug it into point slope form. It would look like this: y minus 3 equals 0, x plus 2. But because if I were to distribute a 0, everything would cancel out. this is point slope form. There is no slope intercept form. So you can say no slope intercept form. But you can write it in the equation of its line. So to do that, you would just distribute the 0. You get y minus 3 equals 0. You'd add 3 to both sides, and this would be y equals 3. So the equation of any horizontal line would be y equals whatever point it's crossing, because it's always going to cross the y-axis. All right, let's do number 8. So number 8, so we're going to start by finding the slope. So we have 1 minus a negative 4 over 5 minus 5. And now this time you'll notice the 0 is in the denominator. And we are not allowed to divide by 0. So it would be undefined. So 5 divided by 0 is undefined. The type of lines with undefined slope are vertical lines. So vertical lines. And our vertical lines, if you had a coordinate plane, so right here, a vertical line is a line that goes up and down. It crosses the x-axis. So here's your vertical line. So since the vertical line has an undefined slope, you can't have, there's no point slope form, and there's no slope intercept form. So the only thing you can do is write the equation of this line. Well, since this line cuts through the x-axis, you want to look at the x coordinate of your coordinate pairs. And since it's both 5, it means that the line is going to cross at x equals 5. Let me try that again. Let me erase this. X equals 5. Okay, so x equals 5. Sorry about that. Not sure why it's not working. So x equals 5. There we go. X equals 5. That's the equation of that line. All right, let's move on to our next set. So the next one here says, I can find an equation of a line in standard form that passes through point P that is parallel to and perpendicular to line L. So first, parallel, you have to know that parallel lines have the same slope and a different y-intercept. Y-intercept. And the reason they have to have a different y-intercept is because if they had the same slope, same y-intercept, they'd be the same line. Okay, perpendicular lines have opposite reciprocal slopes. Okay, so these have opposite reciprocal slopes, meaning if your slope is like a negative 1/3, the opposite reciprocal would be a positive 3. So the first thing you want to do is with line L, you want to put it in slope intercept form so that you can identify the slope. So we're going to subtract x from both sides. So we get y equals negative x plus 5, which means the slope of this line L is negative 1. All right, so for part A, we want the parallel. So I'm going to draw, this represents parallel lines, and the parallel lines have the same slope, so we're going to use the slope of negative 1. And we're going to use this point. So since we have a point and a slope, we're plugging it into point slope form. So y minus 3 equals negative 1 parentheses x minus 0. So right now it's in point slope form, but the question asks for standard form, which means I have to distribute and simplify. So I'm going to get y minus 3 equals negative x. Then I'm going to add 3 to both sides. So I get y equals negative x plus 3. And I'm going to add x to both sides. So I get x plus y equals 3. And now my line is in standard form. All right, part B asks for the perpendicular. This is the symbol for perpendicular. Perpendicular lines have opposite reciprocal slopes. So the slope that we're going to use here is a positive 1. The opposite of a negative 1 would be a positive 1, and the reciprocal of 1 is just 1. So again, we're plugging into point slope. So y minus 3 equals 1 parentheses x minus 0, We're going to distribute, so we get y minus 3 equals x. I'm going to add 3 to both sides. So I get y equals x plus 3, but I need it in standard form, so I'm going to subtract x from both sides. I'm going to do my work over here. So I'm going to get negative x plus y equals 3. I can't have a negative in front of the x in standard form, so I'm going to multiply everything by a negative 1. So I get x minus y equals negative 3. So there's my equation of my line that is perpendicular to line L. Okay, let's go ahead and look at number 10. So 10, the same thing. You want to start by getting line L into slope-intercept form. So we're going to isolate the y. So I'm going to subtract 2 from both sides. So when I do this, I get y equals negative 2. Well, if you notice, y equals negative 2 is a special case. That means this is a horizontal line. And a horizontal line, you can go straight to the equation of the line. There's no computation to do. Remember your coordinates here. This is x, this is y. If you're looking for the parallel line to y equals negative 2, it means it's another line that would have to go through the y-axis, so they're both parallel. So if you look at the coordinates, the y is 1, so that means this equation is going to be y equals 1. If we go to part B, it asks for the perpendicular line. So if this is a horizontal line, a perpendicular line would have to be, the vertical line would have to go through it so that the horizontal and the vertical can make the perpendicular line. So horizontal lines go through the x-axis. So this is going to be x equals negative 4. All right, so there's our 2 lines for number 10. Okay, so first, we need to add something on to number 11. This should say a little colon. This is line L, okay? So just like in those other ones, I should have made this line L. And then what I want you to do is I want you to pause the video and I want you to try this. Remember, your first step is to get line L into slope-intercept form to identify the slope. So go ahead and pause the video. Okay, so let's see how you did. So for the parallel line, we should have gotten 2x minus 5y equals negative 20. And for the perpendicular, 5x plus 2y equals negative 21. At this point right here, the second step, or the third step, I should say, I distributed the 2 to all of them so that I could get rid of the fraction and just work with the whole numbers. If you wanted to wait and do that at the end, you could have added the 2, got a common denominator, got a fraction, and then had gotten rid of the fraction at the very last step when you were doing standard form. But either way, we should end up with the same answer. Okay, let's go to page 3. All right, with page 3, you might want to take out a straight edge and 2 colors, because what we are doing now is we are going to graph these lines. And so it's asking you to graph systems. Systems are just more than one line, so 2 lines or more. And it's saying graph, A, by graphing, and B, either substitution or elimination. All right, so they want us to solve each system. If it has an infinite solution set, specify it and give 3 solutions. If the solution has no solution, say so. All right, so remember when you're doing these problems, you have 3 choices. Either the line's going to cross, they're going to intersect, and where they intersect, that's a solution. So that would be 1 solution. The lines could also not cross and be parallel. Parallel lines would never intersect. If they never intersect, they're never going to touch. So that means they have no solution. And if your line happens to, when you solve it, they are the exact same line, that means they're going to lie on top of each other. And so they're going to overlap at every single point. So that would be infinitely many solutions. All right, so let's go ahead and take a look here. So for number 1, what you want to do first is you need to get y by itself. So you're going to subtract 1/2 x from both sides. So you get negative 2y is equal to negative 1/2 x plus 4. Then you need to divide everything by negative 2. So when you do that, remember, negative 1/2 divided by negative 2 is going to give you negative 1/2 times 1/2. You have to multiply by the reciprocal. So this is going to give us a positive 1/4. So you get y equals 1/4 x minus 2. All right, so for my next one, I'm going to do it in a different color. My second line here, I need to move the x. So I'm going to add x to both sides. and I need to subtract the 8. So I'm going to subtract the 8 from both sides. So I get 4y equals x minus 8. Then I'm going to divide everything by 4. So I'm going to get y equals 1/4 x minus 2. And so now if you notice, they're the exact same line. So I only need to graph it once. So -2 is the y-intercept. And then it's saying 1/4. So I'm going to go up 1 over 4. Up 1 over 4. Or I can start at -2 and go down 1 over 4. Down 1 over 4. All right, so you want to connect those dots. Hopefully you have a straight edge. I'm going to do the best I can. I don't have a straight edge. And so here's my line. So since they are the exact same line, it's one line, we know it's infinitely many solutions. So you can go ahead and write that. All right, they wanted us, if it was infinite solution set, specify it, which we did. We said infinitely many, and give 3 solutions. Well, solution is any point on this line. So right here where we started, that was our first point. So I'm going to go ahead and write that. So 0, -2. Now from there we went up 1 over 4. So that point is also on the line. So that is 4, -1. We also went from -2, we went down 1 over 4. So that's also on the line. So you could say -4, -3. So again, any point on your line would be a solution. Okay, let's take a look at the next one. So you have to put both of these into slope-intercept form. Oh wait, sorry, we forgot to solve it by B, either substitution or elimination. So let's go back to number 1. So now we need to, I'm going to use substitution. Since both these equations say y equals, I can take this equation here and plug it into y. So I'm going to set them equal to each other. 1/4 x minus 2 equals 1/4 x minus 2. Well, right now at this point you could actually stop because you could already tell it's the same on the both sides. And the same on the both sides means identity. So it's an identity. So that means that it would have infinitely many solutions. Okay, now number 2. So for number 2, you need to put both of them into slope-intercept form and then graph them. All right, so pause the video and go ahead and try that. Okay, so let's take a look at our 2 lines here. So these 2 lines intersected at 0, -4. If you notice, they both had -4 as their intercept, so that was the starting place for both of them. And so that's where the 2 lines happen to cross at -4, 0, -4. All right, so we've shown our solution by graphing. Now let's go ahead and show our solution by substitution. So again, since these are both set equal to y, I'm just going to substitute them in for each other. So I get -2 over 3x minus 4 is equal to 2x minus 4. At this point, I don't want to work with fractions, so I'm going to multiply everything by 3. So I'm going to get -2x minus 12 equals 6x minus 12. So here I'm going to add 2x to both sides. I get -12 equals 8x minus 12. So then I'm going to add 12 to both sides. So I get 0 equals 8x. If I divide each side by 8, I get 0 equals x, which is also what I had in my coordinate pair solution. So now I just need to verify the -4. So remember, you can substitute 0 in for x. So I have y equals -2/3 times 0 minus 4. So y equals -4, and it worked. So I verified my solution through substitution. Okay, let's go ahead and take a look at the last one. Go ahead and pause the video and you try the last one. Okay, so let's go ahead and check out number 3. So when you turn this one into slope-intercept form, hopefully you notice they had the same slope but different y-intercept, which meant they were going to be parallel lines. I know mine aren't perfectly straight, but yours should be. So that means no solution because they never intersect. If we did it mathematically, when we plug in for substitution, once you add the 3 over 2x, they're going to cancel out. And you get 3 equals -1, which is not a true statement. So it is no solution. All right, you guys, thank you for watching video 1.